My name is Suraj Yogesh Kavane from third year Mechanical Engineering Department. My name is Aditya Sushil Bakre and I am from third year Mechanical Engineering Department. Our problem statement is static structural analysis of rear underride guard of a truck. Now let's start with the designing of CAD model, and side by side I'll explain why it is important to have a rear underride guard for a truck. Let us start with the chassis. Here we have to make a new component. Dimensions are 80 by 250. I've made the video fast as it requires more time. Each time we have to make a new component as it is important so that the components can move. What is rear underride? It consists of steel bar assemblies connected to rear end of truck trailers. These structural units are designed to stop a passenger vehicle from sliding underneath the rear end of a semi-truck during a rear impact dash. What happens in a rear underride truck accident? An underride collision occurs when a vehicle crashes into the back of a semi-truck trailer and continues to travel underneath the trailer until it comes to a stop. Much of a danger faced by the driver and occupants, especially the front seat occupants, of the crashing vehicle involves the disparity between the highest point of both vehicles to the ground. As I have assembled all the units, now let's make a mirror of one side of chassis to get a complete chassis. Now, as our CAD model is ready, let's analyze by using Ansys software workbench. Now, we are going to assign material to our model, that is structural steel. Here are some properties about structural steel: its Poisson's ratio, its Young's modulus, its density, and etc. Now, as we are going to perform the static structural analysis, let's click on static structural analysis and then import our geometry. After getting a refined mesh, we are going to apply the boundary conditions for our rear underguard. Now firstly, we are going to apply a fixed support to the chassis so that it does not move. After applying the fixed support, let's apply force to the front end where the impact is going to happen. Here we are applying two types of forces. Firstly, we are going to apply 1,50,000 Newton of force and then remote force of 1,50,000 Newton again. So total net force applied is 3 lakh Newton.
These are the maximum values of total deformation, equivalent stress and equivalent strain. Talking about solution, let's find the total deformation of our underride guard. We also need to find out equivalent stress and strain of our model after the impact.